This next measure of concentration is called molality. It is symbolized with a lowercase m, usually in kind of cursive-y form. And molality is the number of moles of solute. So far this sounds a lot like molarity. Moles of solute per kilogram of solvent. Solvent only, not the whole solution, just the solvent. So molality is moles of solute divided by kilograms of solvent. Notice that this is the solvent only, not the whole solution. It's important for you to know that 1 liter of water weighs or has a mass of 1 kilogram. That's an important conversion. Sometimes they'll say, a problem will say dissolved in 1 liter of water. You should know that 1 liter weighs 1 kilogram or has a mass of 1 kilogram. So, if you have 0.25 moles of sodium chloride in 1 liter, which is the same as 1 kilogram, of water, what is the molality? Using the equation, molality equals moles of solute divided by kilograms of solvent. We put the 0.25 moles on top and the 1 kilogram of solvent in the denominator, and the division problem gives us 0.25 molal. With that lowercase m. Do not use a capital M here. It will get marked wrong. Units are important, so make sure that you're keeping track of what you're doing. One method I use to kind of remember which one is molal, we've been talking here about the solvents. It doesn't have to be a liquid, but most of the problems we do, the solvent is a liquid. And all of these L's here in the word molal, molal is all about the liquid. So just the solvent only in the denominator. So find the molality of a solution containing 75 grams of magnesium chloride and 250 milliliters of water. So here we are using the equation molality equals moles divided by kilograms of solvent, and we have 75 grams of magnesium chloride, so the first step is to find out how many moles that is, because I need moles for the equation. So I will start with my 75 grams, and I will use my molar mass of magnesium chloride, which is 95.21 grams, is the same as 1 mole. And if I do that multiplication division, I have 0.78773 moles, although I only really know this to 2 sig figs, so I can round it off there. So this is the value that I plug in to my equation, 0.79 moles in 250 milliliters of water. Okay, 250 milliliters of water is how many liters? Well, there are 1,000 milliliters in 1 liter. And once I have 1 liter, I know that 1 liter is the same as 1 kilogram. So I just need to convert to liters, and then my liters or number of liters is equivalent to the number of kilograms. So when I do the math here, I end up with 0.25 kilograms. And that's the value I put in the bottom of this division problem, 0.25 kilograms. And when I do the division, I get as my final answer 3.2 molal MgCl2. Let's look at another example. What quantity in grams of methanol is required to prepare a 0.244 molal solution in 400 grams of water? Molality equals number of moles divided by kilograms. I know that I want a 0.244 molal solution. I want to know grams, but I can't find that out directly. I'm going to solve for moles first and then convert that to grams. I also don't know my number of kilograms here, but it's easy enough to take grams and divide by 1,000. So I have 0.400 kilograms of water, and now I can solve for moles. I multiply both sides of the equation by 0.400 kilograms. Again, it may be helpful to you to rewrite that cursive M as moles per kilogram if it helps you to see those units canceling out. And 0.400 times the 0.244 gives us 0.0976 moles is our value for the number of moles of CH₃OH. Of course, I don't want to know the number of moles. I want to know the number of grams. So I can take that value, and I know that 1 mole of methanol, when I look up 1 carbon, 4 hydrogens, and 1 oxygen, I have a molar mass of 32.05 grams per mole. The moles cancel out. And 0.976 times 32.05 gives me 3.12808 according to the calculator. But I only need to know this to 3 sig figs. So I'm going to round up 3.13 grams of methanol. Let's do another example. Determine the concentration of a solution with 112 grams of silver nitrate dissolved in 250 milliliters of water. Okay, this didn't actually tell me that it wants the concentration in molal. However, when I'm told the volume, I'm told that it's just the volume of water. It doesn't say the volume of solution. It says the volume of just the water. And that's a clue that we want a molal answer. So molal equals the number of moles divided by the kilograms of solution. Again, here I'm given a number, 250 milliliters for my volume that I want to convert to kilograms. There are 1,000 milliliters in 1 liter, and then 1 liter is the same as 1 kilogram when you're talking about water. So milliliters cancels out, 1 liter cancels out with 1 liter. We're left with kilograms. And so we're just going to use 0.250 kilograms as our mass of solvent. We also need to determine how many moles we have. We're told that we have 112 grams of AgNO3. So 112 grams of AgNO3. I want to know how many grams there are in 1 mole of AgNO3. The molar mass of silver nitrate is 169.88 grams. So when you do the division, you get a value of 0.659289 moles. And of course, we want to round that off to 3 sig figs. So we round it off here, 0.659. So we have 0.659 moles in 0.250 kilograms of solvent, and that works out to be a 2.64 molal solution of AgNO3. Let's do one more example. How many grams of sodium chloride are required to make a 1.54 molal solution using 0.500 kilograms of water? Molality equals moles divided by kilograms. My molality is 1.54. And I'm going to go ahead and write those units as moles per kilogram. And my number of moles is what I'm trying to solve for so that I can ultimately convert it to grams of sodium chloride. And my kilograms are given to me. I don't have to convert anything there. It's just 0.500 kilograms. To get moles all by itself, I need to multiply away this denominator of 0.500. Kilograms cancels out with kilograms. Kilograms cancels out with kilograms, and 0.500 cancels out with 0.500. So when I do the multiplication, I get as my answer 0.770 moles of NaCl are my answer for moles. And now I'm going to use that number to figure out how many grams of sodium chloride. So if I have 0.770 moles of sodium chloride, I want to get rid of moles and convert to grams. One mole is the same as 58.44 grams. And when you do the multiplication and round to 3 sig figs, it's a little bit of a trickier rounding example, so I'll go ahead and show what the calculator says. If we want to round to 3 sig figs, we bump that up, which bumps this up as well, and you end up with 45.0 moles grams of NaCl.